The purpose of this video is to simplify a complex combination circuit. And in order to do that, we have to simplify the circuit down to a single resistance value, which we call the equivalent resistance, which also happens to be the total resistance for the circuit. And what we do is we'll start looking at the resistors furthest from the source. So that would be here on the right hand side of the circuit. And we're going to look for any resistors that are in parallel with each other or in series that do not have any other resistors in parallel with those series resistors. And what I mean by that is, if we look at R6 and R7, we'll see that they are definitely in parallel with one another. If we notice that each side of the two resistors are basically connected to the same point in the circuit, or they're electrically common to one another on each end. There's no other resistors in between these two here, and so we can treat them as if we had two resistors just twisted together in parallel. If we had just three resistors here in series, like if we removed R6 and we had these three resistors, R4, R5, and R7 here in series, that would be the first thing we do. We'd have to combine R4, 5, and R7, which would of course be called R6. We'd have to combine those together first. But since we have these two resistors in parallel, we'll have to combine those first and then add the ones in series. So let's go ahead and do the reciprocal method. You can also do product over sum, but with a scientific calculator that has the reciprocal button, I think it's just very simple to go ahead and punch it in. We have a 100 ohm resistor, and we'll reciprocate it and add it to the 85 ohm resistor in reciprocal. Equals, we get a total value that we have to take the reciprocal of, and we get 45.95 ohms of resistance for our R6 and 7 resistor. So what we'll do is we'll redraw this branch of the circuit of R4, R5, and R6, 7 as our very next step. So we have 45.96 ohms, so we'll go ahead and put that in here. For R6, 7 is 45.96 ohms. 45.95, excuse me, 45.95 ohms. Let's change this. 45.95 ohms for this resistor. And what do we have now in this branch of the circuit? We have three resistors in series with one another. So that's our next step. R4, R5, and R6. Since this is basically a series circuit here in this branch, we have three resistors connected in series. To get that resistance, of course, we treat it as if it's a series circuit. So we just add the resistance values together. So we'll bring up our calculator once again. Let's clear this out. And we have 85 plus 200 plus 45.95 ohms, for a grand total of 330.95. So we have 330.95 ohms for this resistor value. Okay, and I already redrew the circuits for each step, at least most of the way through, just to make it speed up the process a little bit, so I'm not taking time here just drawing out the circuit. So we have this equivalent value for R4, 5, 6, and 7 of 330.95 ohms. And what's the very next step here? Do we add R9 and R8 together and we have two parallel resistors? No, we don't do that. We take it step by step, and we take our equivalent resistance value here for R4, 5, 6, 7 and see what's in parallel with it. And of course R9 is directly in parallel with it. So we have to combine these two resistors and take that equivalent resistance value of R4, 5, 6, 7, and 9 and redraw the circuit with that value. So let's go ahead and calculate this value. We have the 330.95. Let's go ahead and take the reciprocal of that plus the 77 for R9. Take the reciprocal of that equals, and of course the reciprocal of the answer equals 62.47 ohms. So 62.47 is our resistor value for our new equivalent resistance. So 62.47. We'll go up to the redrawn circuit. So we have 62.47 ohms. So this is our, so far this is our new equivalent resistance value. Now we have this resistor and R8. They happen to be, what are they, in parallel? Well, of course they're not. They're definitely in series. So how do we treat two series resistors? We just add them up. So we have R8 here. This should be 50 ohms for R8. So we're going to do a 62.47 plus 50. Well, we kind of do that one in our head pretty easily. We have 112.47 for our new equivalent resistance value. So we'll go down to our redrawn circuit and put in 112.47 ohms. This is our new resistance value for our combined or simplified resistor. Now what's the very next step? Well, you see we have this branch here, two resistors in parallel, which happens to be in series with another resistor. We can't combine this resistance value of R4 through 9 with this branch until we combine these two resistors that are in parallel and then add the two series resistances and then treat that as just a simple parallel resistor and find the total resistance. So our next step is to combine R1 and R2. So we have what we could do also to make a little more room is we can actually just move this circuit over a little bit. This is one of the neat tools on this program here. We can just move the circuits around. Okay, so we have 25 and 50. Let's punch that into our calculator here. 25 reciprocal plus 50 reciprocal equals 16.67 ohms. So we have resistor R1 and 2 of 16.67. So we can go down here and well, we'll draw it here on the side. Let's just redraw this right here. 16.67 is our resistance value. So we'll go ahead and redraw this as just a parallel circuit. So there's our 1, 2. Want it to look halfway decent anyway. Okay, R1, 2, and then R3 right here. And this. So we got that branch, and then we have our equivalent resistor here. So R1 and 2 is here, and R3 is here, and then we have this R4 through 9. Well, we said this is 16.67 ohms, and down here R3 is 63 ohms, and over here we still have the 112.47 ohms. So let's add the 16.67 and the 63, and if we could see that this is 79.67 ohms for this branch with these two series resistors here. So we'll redraw it once again as just two parallel resistors with R1, 2, 3 as 79.67, and we'll go ahead and write that. R1, 2, 3 is going to be 79.67 ohms. Here's our, and this time I'll draw a correct battery symbol, and we just have two parallel resistors. Here we have R1, 2, 3, and here we have R4 through 9. And we said this was 79.67 ohms, and 4 through 9 is 112.47. Okay, now as you see, we just have a simple parallel circuit, so we'll go ahead and calculate this resistance of 79.67 ohms, reciprocal, plus 112.47, reciprocal, equals, okay, reciprocal of that equals 46 point, oh, bring that back up, 46.64, so 46 46.64 ohms for our total equivalent resistance. So for the very final step, if we're going to be drawing this down to its simplest form, we'll just draw it as a battery with a single resistor, and that's our equivalent. Here we have R equivalent, and its value is 46.64 ohms, and there we have it. We just simplified a quite a complex circuit with 9 resistors connected in series and in parallel, and step by step we methodically went branch by branch, simplifying each branch, treating them as series when the resistors are in series, and then treating it as a parallel circuit when we have resistors in parallel. So we have to apply the rules for series and parallel circuits step by step to find the value for the equivalent resistance, or the total resistance of the circuit. Now if we had a voltage source on this, we could definitely use Ohm's law here to find the total current of the circuit, and that'll be our next video. We'll be now calculating the voltage and current through each of these resistors. But for now, here we have it. We've simplified a very complex series parallel circuit and found the equivalent resistance for the circuit.